Before a building becomes a dwelling, it belongs to a place. Welcome back to the Rhino Studio series, and let's get into studio mode. In this episode, we're diving into site and context. We'll look at why site comes first, the basic components of a site plan, and how to trace, contextualize, and annotate it with Rhino. But before we decide where a building goes, what can the site tell us? A site is the first set of conditions a building has to respond to. It defines the project's location, access, orientation, and constraints. Without site context, the project lacks a sense of place. Decisions feel arbitrary, and light and access get ignored. With context, the project becomes grounded, responds to its surroundings, and lets the site inform the design. A clear site plan brings together four main families of information. Property information establishes the legal framework, the property lines, required setbacks, and buildable area. Built and natural context shows what already surrounds the project: neighboring buildings, trees, fences, walls, paving, and topography when it is available. Access and movement describe how people and vehicles reach the site through streets, sidewalks, driveways, paths, and parking. And drawing information, including dimensions, labels, a scale, and a north arrow, makes all of those relationships understandable. Orientation is especially important because it influences daylight, heat, wind, views, and shadow. Sun orientation determines the quality and intensity of daylight a building receives. Morning light is generally softer, while afternoon sun may require additional shading. Prevailing winds show how air naturally moves across the site. Openings can capture breezes for cross-ventilation or be protected from excessive exposure. Orientation determines what the building opens toward and what it turns away from. Buildings and neighboring elements cast different shadows throughout the day and across seasons. These patterns affect daylight, outdoor comfort, and solar access. Lineweight organizes the site plan from lightest to heaviest. Shading sits furthest in the background, adding ground cover and shadow tones without overpowering the drawing. Thin lines describe landscape, paving, and entourage. Medium lines establish the surrounding context through streets, curbs, and driveways. Thick lines give more presence to adjacent buildings. And finally, the building footprint and property line receive the heaviest outline, clearly defining the project and its limits. Before we draw anything, let's look at what we're actually designing. One building carries this whole series: a small accessory dwelling unit, for short, an ADU, a complete one household home of about 1,000 square feet, roughly 26 by 40 feet, or about 8 by 12 meters, so it translates cleanly in both imperial and metric. Now, the site itself. Our lot is a wide, shallow rectangle, about 140 feet across by 60 feet deep. Its long axis running east-west, with the street running down the right-hand edge. It's an infill lot that's already occupied. Near the street sits the existing main house, a larger, irregular footprint with its own driveway pulling in from the road. Our ADU goes into the open western end of the lot, over on the left, set back behind the main house where it can hold its own yard. Beyond the top edge is a neighbor's swimming pool, and along the bottom edge is another neighbor's run of raised garden beds. On our own lot, mature trees are scattered across the property with lawn tying it all together. Now, let's build our site plan together in Rhino. Follow along and pause whenever you need to. First off, open the series template. We're going to start by drawing the lot's property line, and let's be precise about where it lands. Make the heaviest site layer active, the template's site outline layer. Our lot is a simple rectangle, so we'll draw it with the rectangle command. For the first corner, don't just click somewhere on the screen. Type 0, 0 and press enter. Then, for the opposite corner, type the lot dimensions directly, 140 feet by 60 feet, and press enter. That anchors one corner of the lot on the origin, and that point becomes our datum. Next, the setbacks. First, set site thin as your active layer. The setbacks are usually different on each side, say 20 feet along the street edge, 10 at the far west end, and 5 on each of the long sides, so a single uniform offset won't give us what we need. So first, explode the boundary into its 4 separate edges. Now offset each edge inward by its own distance. Because they're separate lines now, each can move its own amount. The offset lines will cross or overshoot at the corners, so trim the overhangs. Then, select everything and join. That closes both rectangles at once. Here's the key move, and it's about how the template layers work. This template uses a print weight layer strategy. The site layers are named by line weight, heaviest to lightest. Site outline carries the heaviest lines, the building footprint and property boundary. Site thick is for major site edges and adjacent buildings. Site medium handles streets, curbs, driveways, and context. Site thin takes landscape, paving, hatch, and labels. And site shade is the faint layer for shading, ground cover, and paving fill. You pick a layer for how heavy a line should print, but customize its object properties to fit different purposes. Let's test it out. The property boundary is the strongest element on the sheet, so it goes on site outline. By default, that layer draws continuous, but a proper property line has its own line type. Rather than building a new layer just for it, we'll override it at the object level. Select the boundary, open the Properties panel, and change its line type from by layer to the site boundary line type included in the template. Do the same for the setbacks with a couple of extra overrides. We drew them on site thin. Then, in the Properties panel, set the display color to a custom red, the line type to hidden, and set the print color to follow the display color so it prints the same red. That hidden red line tells the viewer these are reference lines. Our ADU shares a lot with an existing house, so let's place that first. On site thick, the layer for major edges and adjacent buildings, draw the main house toward the street on the right. It's a larger, slightly irregular footprint. A clean outline is plenty. Now, the ADU footprint. We're not designing the building yet. That comes in later episodes. So at this stage, it's simply a rectangle marking a preliminary location. It's also a good moment to show a precise way to enter dimensions, relative coordinates. Start the rectangle command and pick a point for the lower left corner over in the western end of the lot. Then, instead of clicking the opposite corner, type R 26 feet, 40 feet, and press enter. With the footprint drawn, use Gumball to test where it could stay on the site and its rotation. It could be placed horizontally or vertically, but for now, we'll position it vertically. Then place it on the site outline layer. Now, add the context that shows how the project relates to its surroundings. Begin by drawing temporary boundary lines 15 feet beyond the property lines. These will define where the site context ends and can be deleted once the drawing is complete. On site medium, start with axis. Offset the street edge by 8 feet, then use extend so the lines meet the temporary boundaries. Add the curb and driveway, then copy the property lines to establish the neighbor's lots on both sides. Next, switch to site thin and draw the neighboring houses. For one property, use curve to draw a swimming pool. For the other, create a garden by drawing a 4x4 foot square and running array. Set the array to 7 items in the X direction and 2 in the Y direction. Use a spacing of 6 feet in both directions to leave 2 feet between each planter. Then switch to site shade and run hatch. Select the areas you want to fill and press enter. Choose the sand pattern and adjust its scale until the texture reads subtly. Let's also hatch the ADU footprint, as that will help it stand out from the surrounding context. Finally, copy the tree, parking space markers, street lamp, and car blocks from the template. Assign them to site thin and place them throughout the site. Once everything is in place, use send to back or bring to front to control which elements appear in front or behind others. Finish by adding the information someone needs to interpret the drawing. On annotitle, run text and label the main house, ADU footprint, neighboring houses, pool, and garden. A quick way to center text within an object is to draw a diagonal line from one corner to the opposite corner. Then, turn on Center in OSnaps. Select the text from its center point and place it at the midpoint of the diagonal. Once it's centered, delete the diagonal line. Repeat this step for the rest of the labels. Property line lengths are typically written directly on the drawing, so add the 140-foot and 60-foot labels. Next, run dim to add important measurements, including the size of the ADU footprint and its distance from the property lines. To keep the dimensions aligned, choose continuous after placing the first one. This allows you to select multiple points and create a connected series of dimensions. Finally, turn on Print Display and review the drawing as a whole. The ADU footprint and property boundary should read first, followed by access and surrounding context. Landscape patches, setbacks, dimensions, and annotations should support the drawing without competing with the project. Now, let's export the finished drawing as a PDF. Go to File, Print, and choose Rhino PDF. Choose your page size and orientation, then make sure the output color is set to print color. This ensures the PDF uses the print colors and line weights we assigned to the layers. Under the View and Output scale, choose Window and click Set. Draw a window around the area you want to export, then press Enter. You can adjust the scale manually, but ideally, the drawing should use a standard architectural scale appropriate for the sheet. Use this reference guide to choose the appropriate imperial or metric scale for each drawing type. Once the scale is set, click Print to export the PDF. Your finished drawing should look like this. Now, let's pull everything together. Site gives the building meaning, so we learned to draft context, streets, and building footprint. Orientation shapes light and response, which helped us connect plan to site and design with purpose. And hierarchy makes drawings readable, so we learned to annotate for clarity, orientation, and site use. For this episode's exercise, draft a simple 2D site plan in Rhino. Draw the property lines, the street edge, and the building footprint. Add the surrounding context and organize it all with a clear site hierarchy. In the next episode, we'll cut into the building and develop the floor plan in greater detail. Download the template and the full episode guide using the link in the description. Like this video and subscribe to follow along with the full Rhino Studio series. Studio life comes first, and the Rhino Studio series supports us. We'll see you in the next episode!